So we've been talking about sine and cosine functions, graphing them, stating properties, graphing transformations of them, and then given their graphs, writing equations of them. Sine and cosine functions we call sinusoidal because they take a wave shape, okay? We also call them periodic because they repeat the same shape after a certain period. What we're going to do with tan is just see what it looks like on a graph and see a couple of properties. That's all we're going to do with tan. We're not going to do transformations of tan. We're not going to do, given a graph of tan, write the equation. Just want to show you what the basic tan graph looks like, along with a couple of properties. So when we first started graphing sine and cosine, we did a table of values to see what the sine and cosine graphs look like. We're going to do the same thing with tan. So instead of x, I'm just calling it theta, and these are in radians. And then y is going to be the value of the tan of whatever angle in radians. So thinking back to your unit circle, remember to find the tan, you take the y coordinate at that corresponding point on the unit circle, divide the x coordinate. So what would the tan of 0 be? Well, at 0 radians, that's the corresponding point on the unit circle. What's y divided x? 0. At pi over 4, the corresponding point on the unit circle is root 2 over 2, comma root 2 over 2. And the tan of that would be y divided x, which is 1. At pi over 2, the corresponding point on the unit circle is 0, 1. The tan is y divided x, which is undefined. So we got to figure out how do we graph undefined. And then if we continue on, 3 pi over 4 is negative root 2 over 2, comma root 2 over 2. So dividing the y by the x gives us negative 1. Pi is at negative 1, 0. 0 divided negative 1 is 0. Five pi over 4, the corresponding point is negative root 2 over 2, comma negative root 2 over 2. Negative 1. Or sorry, positive. Actually, 1. 3 pi over 2 is down at 0, negative 1. That gives us another undefined. You can see that we're starting to repeat. 0, 1, undefined, and in fact the next one is negative 1. And then it starts back to 0 again. So just looking at that, that tells us that it's periodic because it repeats the same shape over and over again. But it's not going to be a wave shape. This is the shape it's going to take. So let's, we've got pi over 4, pi over 2, 3 pi over 4, pi, 1, 2, 3, 4. So I'm going up by pi over 4s. So that would be 2 pi over 4, which is pi over 2. That would be 3 pi over 4, 4 pi over 4, which is pi. 5 pi over 4, 6 pi over 4, which is 3 pi over 2. 7 pi over 4, and 8 pi over 4, which is 2 pi. So the tan of 0 is 0. I need one negative one on my graph. The tan of pi over 4 is 1. I'm going to skip the undefined for a second. 3 pi over 4 is negative 1. Pi gets us back to 0. 5 pi over 4 gives us 1. 3 pi over 4 is undefined again. This is negative 1. And this is 0. And then we could see the pattern would keep repeating. Wait a minute. I put that at the wrong spot. That should be there. So we can see we go on the x-axis 0, up, and then undefined, and then down, x-axis up, undefined, down, x-axis. I could see the next one has to be up, just like the next one over here has to be down. But what do I put it undefined? Oh, I thought you said something. I'm looking at Ellie. Oh, okay. How do we show nothing on the graph? It's a challenging question. You've taken it before, but you may not remember them. Not quite, but you're on the right track because it can't be anywhere along here, can it? So if I put a whole bunch of hollow circles, I'd be drawing infinite hollow circles. But you're on the right track. Yes. It cannot be anywhere on this line. Do you remember what we call that? Asymptote. Specifically, a vertical asymptote. Well done. So every time there's an undefined, we have to put a vertical line. Dash line with arrows on the end because it goes forever. Because the graph can never touch here. It can be before, it can be after, but it can't be on it. So what is this shape going to look like? Well, if we were actually to start taking values in here and figuring out the tan, they would get higher and higher and higher, bigger than 1. It's actually going to look like this. As we get to pi over 2, which we know can't exist, the value of tan gets higher and higher and higher, but it'll never hit here. Just like on the other side, we're down here, the tan of angles between these two notches will get lower and lower and lower, but it'll never get there. And it's going to take a curved shape. So let me draw that. Yeah, that's not the greatest, but it's going to take a curved shape. So we're going to have a series of kind of stretched out S's. And that's what tan looks like. Okay? You should be familiar with what tan looks like. You should be able to say where a vertical asymptote would be. And you should also be able to state these properties. The amplitude. What would the amplitude be? Yes. So, because it goes up, right? So we would never get a value for the amplitude, would we? because it kept going up and up and up. So you're on the right track. So actually there's none. There's no amplitude. Because it just keeps going up. We can't count it. The period. How long does it take for the curves to repeat themselves? Well, isn't this a period here? And this would be a period here. And then if we stretched it out, that would be another period. So how long is 4 notches? Pi. So the period would be pi. I'm going to skip the domain for a second because that's a little, you got to be careful with that one. The range is pretty easy. Negative infinity to positive infinity. Sideways. Or YER. The y-intercept is pretty straightforward too. 0. The domain. Well, the graph keeps going. It's a series of curves that keeps going to the left forever. And it keeps going to the right forever. Except there are certain x values where it's not defined, is it? So I can't say negative infinity to positive infinity because it doesn't include pi over 2. It doesn't include 3 pi over 2. It doesn't include the next one after that or the ones before that. So this one would be, where am I here? This would be -1. This would be undefined. Okay, so it would be negative pi over 2 would be the next one. So how do I write, well, it's everything, but not these ones. We did it last year when we had asymptotes. And what we did is we said, okay, instead of saying what the domain is, we're going to say what it isn't. And we know that it's not pi over 2, right? So we know it's not pi over 2. And then if I go, remember each notch is pi over 4 here, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. If I add another pi, I get to another one that's not. If I were to subtract the pi, I get to another one that it's not. So if I kept adding pi's forever, I would get to ones that it's not. And if I kept subtracting pi's forever, how do we write that? Every pi. So the first pi, the second pi, the third pi, the fourth pi, the negative first pi, the negative second pi, the negative third pi, plus pi k, where k is an integer. So this means can't be pi over 2 and 1 pi after that, and 2 pi after that, and 3 pi after that. Also can't be pi over 2 and -1 pi after that, -2 pi, going the other way. And we have to use the same kind of reasoning for the x-intercepts. Any idea? Because there's infinite x-intercepts, right? There's one at 0, there's one at pi, there's one at 2 pi. When would the next one be going to the right? 3 pi, and the next one. Right. If I go this way, what's the next one? -pi, -2 pi, -3 pi, -4 pi. So it's every pi times 1, 2, 3, 4,
-1, -2, -3, -4.
Or K, where K is Z. Just loves giving me these things here. So the zeros are going to be every pi plus pi k
Or I could have done 0 plus pi k. That would work too. Either one would work. Okay. So that's everything you need to know about 10. Okay.
And like I said, that's